Hi guys, my name is Michael, and welcome to this little talk on real data collection and aggregation using Spark Streaming. What you see here is actually a live demo of real data collection and analytics using Spark Streaming, Kafka, and HBase. So in this video, I am going to walk you through the architectural overview of everything that takes place and what this whole thing is all about. First and foremost, let's talk about what these things mean: distribution of trajectory and distribution of users, and by different dimensions. The data set and everything that you see that's been streamed as data was actually gotten from the website. Um, it's T no, not this website. It was gotten from a geo live trajectory um, website from Microsoft, a research from Microsoft. Yes, that is it. So um, this is the official site for the download, and I have downloaded it, and it is currently in this document. So this is just a dataset from the Microsoft research in Asia, and dataset was collected over a 5-year period from 2007 to 2012, and it's just about people who carried sensors around or GPS enabled device, and they allowed the tracking of their movements using these devices. And this data set contains about 17,000 trajectories. And what trajectories actually mean is a series of points for each movement. So one trajectory could take up to X number of data points. And this data contains longitude, latitude, altitude, and other things, right? So the total trajectory covers about 1.2 kilometers and a duration of 50,000 hours. So it is used for various kind of research like mobility, pattern mining, user activity recognition. And in this case, what I did was I created a streaming version of this data set, and I want to now use the and derive real-time analytics of these four graphs you see here. So like the first one is the distribution of trajectories by distance. So you want to see for each trajectory how many distance was covered. So you can see for less than 5 kilometers it happened 36% of the time, for this 36% of the time. So these graphs, as you can see in the document, in this final document from Microsoft Research, is at the end of the entire data set. Whereas what we have is we have a streaming version of this graph that should converge at the end of the day. So I will, the application that's doing the streaming, it's, I can show you right here. Okay, yes, it is using 5 concurrent threads to read the files from the downloaded version. So this is the file that was downloaded. And these are the 182 users that were tagged. 182 users that were tagged. But however, I used a simple application to compress them into 5 different places, and so that I can create 5 threads to read them concurrently. Now they are also arranged in chronological order. So the data in each file are sorted according to time, so that we can really mimic the exact scenario. So the data starts streaming, and in this video, I'm just going to show you the high level architecture rather than the details, the technical details. In other videos, I'm going to come up in a video shortly. I'm going to come up with the technical details. So having seen this, the documents, this is what we're trying to get. This is the final at the end of the entire data. This is what we should see, but at every point in time, the details will continue to change as more data gets streamed in. Okay, so let's go to the architectural diagram. um, this is what actually drives this application, right? So we have the 5 sensors as sensor simulators. So these are just applications. It's actually one application with 5 threads, like I showed you right here. So and each thread will be reading each of the file and sending it at real time to a Kafka broker server. Now, the Kafka server is on this IP address, which is actually my VM, which is actually this VM, but it's on a it's on a network that is connected to my Wi-Fi, right? That my Wi-Fi at home. So they stream down to a Kafka broker, and the Kafka broker now serves the an Apache Spark streaming service that you just saw. From the Kafka broker, it gets to the Spark streaming service. From the Spark streaming service, some computations are done, and some of this computation requires data buffered in a caching server that is powered by a Redis server. So sometimes it goes to Redis and caches running totals, and sometimes it just stores some buffer value to track the next location or the previous location of the user in the entire trajectory. Then when it finishes that, it sends the data back into Kafka, or it saves some of the data to a NoSQL HBase database and sends the signal back to Kafka, where to another topic where the data is captured by the dashboard. So this dashboard is reading from the server as well, from the Kafka broker as well, from another topic. Then once the dashboard retrieves the data, it merges it with the data that has been saved to HBase using Apache Phoenix, right? Because the HBase database cannot give me, it's not very flexible in query. I have Apache Phoenix in front of it, and that allows me to write those simple aggregate queries that were not possible if I was just working with HBase on my own. So eventually, you capture the data in the dashboard, and that is exactly what you see right here. So as time goes by, as more data gets captured, you will see that this graph keeps changing. And like I said, by the time we have streamed all the uh, millions of data points that we have, we should converge at this level. We should converge at this, right? So at this time, 5 kilometers is 36%. A final stage should be 36. But you can see now from here it is still 62%, and 5 kilometer is just 25%. But things will grow as more data keeps coming. So now what I'm just going to do in the overview is just take you through each part of the architecture. For example, the sensor I just showed you is a Java application that will read the files from the path. Where is it? Okay, that's the path right here. It reads it from this path, right? And it sends it to this broker, this Kafka broker server, and that is the VM actually, but in this IP address, and sends it to this topic. So that's all it does. It does that by spawning 5 threads, and each thread will be reading this file and sending it to the Kafka server. Now let's go into the VM and see what the Kafka server looks like. Okay, this is Redis. We'll come back to Redis later. Let's see what the Kafka service looks like. You cannot see it streaming, but the easiest way for me to prove that it is streaming is to use a console consumer. So this is the Kafka console consumer that comes installed with Kafka. And this is the topic, and this is the Zookeeper instance. Okay, in the architecture diagram, I did not show you, but Zookeeper actually powers Kafka and HBase. So I installed a separate instance of Zookeeper that powers both Kafka and HBase at the same time. Okay, so if I enter this, you would see the data streaming on the topic. So yes, this is how the data actually arrives at Kafka, right? So what Spark streaming is actually doing is just processing the data in a D stream, a discretized stream, 250 milliseconds apart. right? So that, but this is the way Kafka is getting the data. So uh, the only difference is, if you look at it, it's one line per record. So it's just one line per record. The only difference is that, let me show you how the lines are from the documentation. Yes, every line comes like this, right? But it's just coming rather fast, and that is why you're seeing it run that much. Okay, so once the data gets to Kafka, it sends from that. It's captured by Spark streaming on that topic, right? And you already seen the Spark streaming screen just running. I can stop this right now. Right. So the Spark streaming is, this is the console for the Spark streaming. It's just doing its work, and it should run forever. Right? It should run forever. The command that I use to start Spark is, I have the commands here. All the commands for that, it's this Spark submit. So I packaged it as a jar using Scala and SBT, and it runs like this. So once the data gets to Spark, like I said, it stores some running totals and some temporary values in Redis. I used Redis because I didn't want to use HBase as a kitchen server, because definitely Redis is going to perform better, and I want to make sure I finish all the calculations at least within that 250 milliseconds. So I wanted something that's blazingly fast, and the key value stores kind of databases were made for that, right? So Redis is actually serving all this data. And to give you an example of that, I can go to the Redis client and try to look at the data. Sorry, Redis client. And I can get, if I could get an example of one of the, if I could get a handle to one of these, okay, yes, this trajectory, I could look at it. So there's actually a variable I'll call give me the last latitude or the last longitude of that. That should be something like this. I know this because I wrote the code, right? So get this, it's nil. Why is it nil? Latitude get, if I am correct, that should return something. Longitude nil. Okay, then I'm not using the right one. TS nil. Okay. Let me get another value. Let me get another value. This is user, this is trajectory. So let me try another one. Yes, because there are chances that it will be nil. You mustn't always have value. If it has never been stored before, obviously it will be nil. Let's try something else. Nil. Okay, we have a lot of nils right now. But that is the server that's used to interact. And if you watch out for the video, okay, we have 18 here. We have another one here. If you watch out for the video, you would, if you watch out for the next video where I will talk about the technical details, it will all make sense. Okay, I have a lot of nils, but you watch out for that video, it will all make sense. So what we just do with Redis is hold running totals, and we use it to hold running totals and keep some pre-calculated values that will change very frequently. Okay, so next in the sequence is when the data gets to the running totals and all these values have been calculated, they will be populated to a column family on HBase. They will be populated to column family on HBase, and two different tables, let's call them tables or column family, are actually populated. And I could show you that on I'm certain I'll have data this time, right? Oh, right? So if I open HBase, by the way, I have all these services started. So if I show you the list of services that I have, you can see HMaster is for HMaster, and HRegion is for HBase. Spark Submit is currently running. The Quorum PM main is the process for Zookeeper. Resource Manager, Name Node, and that's for Hadoop, HDFS, and Yarn. And Kafka is for Kafka, of course. So you can see all the processes running, and you see Node4j sorry, not Node4j, Redis running right here. So if I list the tables that are concerned, the only two tables I'm using right now is movement and movement by trajectory, by traj. So if I scan just one move table, I will see that's a lot of data, right? So it's arranged in time series, user and timestamp, right? User and timestamp, and arranged in decreasing order. Okay, while we talk, data is being loaded, and you can see values are changing frequently. And other table is by traj, right? This one should contain a lot more data. This one is trajectory versus timestamp as well. It's also arranged in a time series fashion. So I used kind of design patterns for time series kind of database. Then once that, but you see, we cannot query it very well, and that is the problem why I had to deploy Apache Phoenix, and it's really awesome. So if you look at the architectural diagram, the dashboard does not interact directly with HBase. It goes through Apache Phoenix. So Apache Phoenix now gives me a very good SQL-like platform where I actually run queries, and the dashboard actually connects to Apache Phoenix using a JDBC driver. So I just treat it like I'm dealing with another RDBMS. So and it really allows me to do flexible stuff. So let's go to Apache Phoenix on command line. This would be, and the name of this server, data box, that is the name of this server, the name of the server. So if I hit Apache Phoenix, and I can see, so what I did was on those tables in HBase, I built a view on Apache Phoenix to feed data from it. So I built that view, and the names of the view are still the names of those tables. So I have movement and movement by trajectory. So right here now, I can now run select statement as though I was dealing with uh, movement. Just give me only 10 records, and that is it. That is data for me. Then you can see I can actually run analytical queries now, like select this star sum by. I can run this kind of query, and these are the queries that are just being run by the dashboard against the database on getting new data from Kafka. So you can see this is what query is this. Give me the sum of the duration for a trajectory, and give me the number of trajectories, distinct trajectories by each user, right? So these are the things that, for example, this is give me the sum, the difference. These are seconds. So we will now convert those seconds to time. And let's see, this is 1 hour. This is between 1 and 6 hours. This is 6 to 12 hours, and this is over 12 hours. And the distribution by trajectory is populated by which other table? Going to be this table. So we have about two that are between 10 and 50. Then we have the rest are below 10. Then as we get more data, you will see some are between 50 and 100, and some are just above 100. So like I said, we will gradually converge at this point. We will definitely converge. By the time we have finished streaming in all the data, we will definitely converge at this point. Okay, so you have now seen how we work data at real time through these various integrated systems and how they work. I hope it's you have learned something from this. And by the way, this was done in a class that is offered by Desire.com. It's Desire.com. I actually taught this. Uh, yes, this is my profile, and we have courses on big data and certification and Hadoop training. But this was actually taught on Hackaday. Hackaday is actually real life interactive and instructor-led project, and this was just done 24 hours ago. Is it 24 hours ago? Yes, 24 hours ago, right? So the students in this class had the privilege to see the live coding, right? How we um, wrote this in in real class, and they saw the bugs, right? They saw the bugs, they saw the success and everything. And if you partake in sessions like this, you get to see live coding, such like Spark streaming, Scala, stateful transformation of streams, HBase, Spark integration, decoupling real-time data pipeline using message broker, which is Kafka in this time, and displaying that information on a dashboard. So this was done, but we have the privilege to share this on a video to just show you the architectural overview. And the next video I'll be doing afterwards will go into details where I would show you some of the codes in Scala for the Spark engine. I will also show some of the code in for the dashboard as well. So you want to check for the part 2 of this video. Thank you.